Let us look at proposition number 31 of book 9 of Euclid's Elements. The proposition says, if an odd number is relatively prime to any number, then it is also relatively prime to double it. So here A is an odd number, B is any number, and they are relatively prime to each other. If that is the case, then A will also be relatively prime to double of B. Let's see how we can prove this. Given an odd number A and another number B relatively prime, let C be double of B. So C is double of B. Assuming A and C are not relatively prime, we have to prove that they are relatively prime. So since we are using proof by contradiction, we are assuming the opposite. Now, if they are not relatively prime, that means some number measures A and C. Let it be D. So this D measures A and C. Now, A is odd, therefore D is also odd based on our previous propositions. Now, D, an odd number, measures C. So C is even. Now, in our previous proposition, we have seen that if an odd number measures an even number, then it also measures half of it. So D measures half of C, which is B. Remember, C is double of B. So that means B is half of C. D measures B. Since D measures half of C, which is B, that means D measures B. D measures A and B. So here we have seen some number measures A and C, so it measures A. And here we are saying D measures B, so that means D measures both A and B, which is not possible since A and B are relatively prime. So that means we have reached a contradiction. That means our assumption was wrong, and our assumption was A and C are not relatively prime. So that means A and C are relatively prime. That is proposition number 31 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.